practicing the basic rules of derivatives and then the simplification just so you can see it. All right, so the first one's a simple polynomial. And so again, we think about it as having four little functions. There's the little power function x cubed, there's the little power function 9x squared, there's the little linear function 15x, and then there's the constant function 25. And so when I take the derivative of this, and I'm going to kind of skip those middle steps that we were doing. If you need to do those middle steps, where we kind of add out all the rules like I did in the last examples, feel free to do that. Especially, and I encourage you to do that the first few times you practice this. All right, but I'm going to just go ahead and do the finding the derivative sort of in my head, kind of do the mental step. All right, so x cubed power rule, I pull the 3 out front, take my cube and subtract 1 from it. So the power rule is the derivative of x cubed is 3x squared. Minus the negative 9 will come along, but I'm not going to write it down because I know I'm going to pull the 2 out front and multiply it by my negative 9 to get a constant of negative 18 out front. And then it's going to be x raised to the 2 minus 1. So x raised to the first degree, and again, we don't usually write the first degrees down. And so the derivative of negative 9x squared is negative 18x to the first. All right, the next one is, excuse me, the derivative of 15x. Well, the 15 is going to come along. The derivative of, remember, of just x is 1, so you just get 15. And again, I'm not going to write it down, but I'm going to talk about it. 25 is a constant. When we take the derivative of a constant, that just zeroes out. And so there's the derivative of that function. Right? And that one's actually completely simplified. I don't need to do any more work there. All right, the next example has 3 functions. There's the 2x function, the 4x, and that's a power, 3 halves, so that would be the square root of x cubed, and the constant 500. All right, so the derivative of this, well, the derivative of 2x is just 2, right? 2 comes along, derivative of x is 1, plus the 4 is going to come along, but I'm going to multiply my 3 halves by it. And I'm going to write this one out because it's a fraction. Students typically have trouble with fractions. So I'm going to write out 4 times 3 halves. X raised to the 3 halves minus 1. So 3 halves minus 1 is going to leave me with 1 half. All right, and I'll have to clean that up. And the last one's just a constant of 500. Even though it's 5,000, even though it's a big constant, it still zeroes away because it's constant. All right, and then rewriting that more simplified would be 2 plus 6x to the 1 half, or 2 plus 6 square root of x. But since they didn't do square root in the first one, this is probably the way it would write it in, even on my lab. Alright, so the derivative of the p of x is 2 plus 6x to the 1 half. Alright, next example, f of t. So this one's simple, other than the numbers are ugly, but a lot of times in applications the numbers will be ugly. And so this is just the power function. There's only one function. There's the constant out front, and then t raised to the power 1/9. So the derivative of this, again, I'm going to write it out since the numbers are ugly. The 128.1 is going to come along, and then I'm going to multiply that. So I'm going to put that in parentheses. 128.1 in parentheses times parentheses. I pull the power out that's on t. Well, it's a power 1.95, right? That's the power on t. So that gets pulled out front and multiplied. And then I take t raised to 1 degree less. So 1.95 minus 1 is going to leave me with just 0.95 in the exponent. And then I'll multiply that out. Again, it's an ugly number, and I'm going to write it out exactly. So 249.795 when I multiply it times t raised to the 0.95 would be the simplified derivative. All right, and so again, the numbers were ugly, but that's what the derivative is. It just follows the power rule. All right, next example. So before I get started on the next example, I'm actually going to rewrite this. So I've got the 2x. That stays. But I'm going to rewrite the 1 over the square root of x as x raised to the, well, first of all, I'm going to move it up so it becomes a negative, and then the square root is the 1/2 power, so it's x raised to the negative 1/2. That came from, again, the fact that this was x to the 1/2, right? When I rewrite the square root, and then when I move it up, it becomes a negative. Right, the 1 over x, same thing here. I'm going to move it up, so when I move it up, it becomes a negative. There's an understood 1, and so when it moves up, 1 over x is exactly the same as x to the negative 1. All right, now I can take my derivative because I've got power rule, power rule. All right, h prime of x, the derivative of 2x is just 2, right? Because derivative 2 comes along, derivative of just x is 1. This is a power rule. I'm going to pull out the power negative 1/2, so I'm going to get negative 1/2. X raised to the, make sure you're careful with negatives, is subtracting. So negative 1/2 minus 1, and you can use your calculator, comes out negative 3/2. Alright, next one, rewrite. So now I'm going to pull out my negative 1, so I'm going to get negative, and we don't usually write 1, even though it's a negative 1 there. So it's going to be negative x raised to the minus 2, right? Negative 1 minus 1 gives me a negative 2. And again, there is a negative 1 in front. We just don't typically write it. So if you want to write it, it's fine. But then when we do go put it in, we usually leave it. This is more the proper way. Other than, again, I'll clean it up a little bit. So right now, if this were a test question or a quiz question that I wrote, you can leave it like that. On my lab, it depends on if they're asking you for the exact answer or not. So if they ask you for the exact answer, you will have to rewrite these without your negative exponent. So this would be rewritten as 2 minus, this is going to move down here with the 2, x raised to the 3/2. Oops, I forgot my 2. Move down there with the 2. I said it, I didn't write it. So 2x to the positive 3/2, right? When I move it down with the 2, it's no longer a negative. And same thing here. I'm going to move this down, and so it's going to become 1 divided by x squared. And if they make you rewrite this, that would be the square root of x cubed. If they're writing it completely exact. Again, I don't know what they're going to ask for exactly because it changes, but if they do ask for exact answers, sometimes that's how they write it. So make sure, again, you get to, one thing about the homework in my lab, you can try it more than once, and they do have a help key where you can ask for help how to input stuff too. So utilize that as well. Alright, so the last example here. So this is sort of a messy one where I've thrown everything at you. And a lot of times this is how they ask these types on the final because it kind of throws everything at you. Alright, so I've got my power function. I've got to rewrite that, and those are fine. Alright, so I'm going to rewrite. I'm not taking my derivative yet. I'm rewriting the division 1 and I'm rewriting the root 1. Alright, so the first one's fine. 2x to the 3.1. Minus, I'm going to move my x to the 5th up, so it's going to be 4 times x to the negative 5th. Plus 4 times x, I'm going to rewrite this as 5/2, as the exponent 5/2. Minus x minus pi. Alright, there's my messy function. Alright, now though, power rule, power rule, power rule, power rule, constant rule. Alright, so 2 times, so 2 would come along. I'm going to multiply by my 3.1, so I'm going to get 6.2. Right, when I multiply that out, I'm going to get 6.2. X raised to the 3.1 minus 1 is going to be 2.1. Alright, same thing here. My negative 4 times my negative 5 is going to come out positive 20. X raised to the negative 6. If I'm going to make a mistake, this is where I typically make mistakes, is with negative exponents, sometimes I'll add instead of subtract. So make sure you're careful there. It's an easy mistake to make. I subtract 1 from negative 5, so I get a negative 6. Alright, plus 4 times. And now with the fractions, since students sometimes struggle with fractions, I would encourage you to write it out. But you do get to use your calculator, so you could just take your calculator, take 4 times 5/2. I know the 2 is going to cancel with the 4 and give me 2 times 5, which is 10. Alright, or you can plug it in your calculator. It should give you, if you take 4 times 5/2, it should come out 10. X raised to the 5/2 minus 1, which would be 5/2 minus 2 over 2. And so that gives me 3/2. That's a positive 3/2. Derivative of just x was 1. There is a negative out front, so it's going to be negative 1. Pi, remember, pi is just a constant. It's an ugly constant, irrational constant, but it's just a constant, so the derivative of just pi will 0 away. And there is my function. All right, and I'm going to leave it like that, because usually within these cases they do leave it because you've got the decimal and the exponent there. All right, so we'll leave it like that. So that finishes up this sort of portion of notes where we're practice. So make sure you practice them. You cannot learn these rules without practice. Practice, 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 practice. Go on and look at my extra practice worksheets, which I have keys to. Maybe redo these on your own. Look at some of the book problems and make sure you go on and do the online homework.